X plus square root of 12 equals 3 square root of 3.
Can we get rid of David?
Just because I'm brown.
Basically.
Listen, why did we have to bring her
Hey.
back? We could have left her
Honestly,
there.
though.
I wanted
See?
to stay
It
there.
was quiet.
It was nice.
Cooper.
It was quiet.
You know, some of us
It
actually
was more
smile.
peaceful. Shh. Okay.
It's definitely quiet, that's for sure.
Yeah, because, you two weren't yelling at each other. Square root of 12, what does that simplify to?
2 square root of 3.
Yeah, 2 square root of 3. Can't make me do that every time. If you have a nice calculator, it does that part automatically. You can kind of use a calculator on this. How do I solve that for x? Subtract 2 square root of 3. So what is 3 square root of 3 minus 2 square root of 3?
1.
Yeah, 1 square root of 3 or square root of 3. You do need to show some work, not just the answer. Jordan, do you hear that? David?
Yes.
You
I'll
said
do that
don't
one
show
too.
your work, just put the answer.
You want to have credit? Yeah, sure, let's do that. Number 3, x squared of 20 minus 3x squared of 5. Equals 8. Alright, can we simplify anything on the left side?
You can.
Yeah.
Yeah.
2 square root of 5.
20. Now, square root of 5, that's too simple, right? But this, is 2 square root of 5. So we got the x, we usually just put between the number and the square root. You don't want to put the x at the end because then it looks like it's under the square root. You don't want. Okay, can we simplify anything else? Are these like terms?
Yeah.
Yes. So we have 2 of these minus 3 of those is negative 1 of those. Okay, how do I solve this for x? How do I get x by itself? What's happening between the x and the square root of 5 here? Yeah, it's multiplied by square root of 5. So I need to divide by square root of 5, but actually, what about that negative? Yep. It's kind of like a negative 1, and you could put it on the square root of 5. So we need to really divide by negative square root of 5, like that. We need to get rid of it. So that will clean that up. Okay, so this is what we did yesterday. You can't leave a square root in the denominator. So remember what we did? We multiplied top and bottom by square root of 5. So it's 8 square root of 5 over 5. But there's a negative, so it's negative 8 square root of 5 over 5. What was that, number 3? Yeah. Number 5, solve each radical equation. Check for extraneous solutions. You guys know what the word extraneous means? That's a big word. Anybody want to impress me with their genius intellect?
Big.
David has no genius intellect.
Anyway, extraneous means
Expensive.
kind of like extra, like stuff that, I don't know, I think of like the gristle you have to cut off meat. So sometimes when you use the tricks for like number 5, like we're gonna have to square both sides. When you use that trick, sometimes you'll get an extra answer that doesn't actually work. So what we have to do is plug it back in and make sure they work. Okay, so anyway, number 5. It's actually a pretty short problem. Number 5 is 8 squared of x equals 40. So still trying to get x by itself. So what do you guys think we should do first?
Divide by 8.
Divide by 8. Since 8 is multiplied to the square root. So I get square root of x equals 5. And how do I get rid of the square root? Square it. So x equals 25. Okay, when you use the square trick, like we square both sides to get rid of the square root, sometimes you get an answer that doesn't actually work. I'll give you a hint though, it usually looks more like this. So that would be x equals positive 25, but usually those don't work. Sometimes they do. So basically we just got to plug it back into the original and make sure this works. So what's the square root of 25?
5.
Times 8, so it does work. So we're good. If it didn't work, guess what I would have put? No solution, yeah. Number 7, instead of x to the 1/2, what's another way I could write that on number 7?
X to the 0.5.
Well, that's true, but with the radical,
I don't
with
know.
the
it's
radical
hard.
symbol, what do we,
Square root of x.
square root of x? You guys remember what x to the 1/2 meant? It means x to the first to the second root. So basically, it's square root of x. X to the first to the second root. So plus 2 equals 9. How do I solve that for x?
Minus 2.
Minus 2. Square root of x equals 7. Then
Square it.
square it. So x equals 49. And we need to make sure 49 actually works. Square root of 49 is 7 plus 2
Mhm.
is 9, which is true, so that's actually right. Hopefully one of the odds gets one that doesn't work. Yeah. Number 9. Square root of x minus 8 plus 9 equals 2. It's a little bit different. What do you guys think I should do first? Get rid of the plus 9. That's correct. So I'm going to minus 9. Oh, why do I not do minus 8 plus 9 right there? Yeah, this is not really an 8. It's not even the square root of 8. But because really you have to do x minus 8 first and then square root it, so it's something weird. Anyway, it doesn't mix. Basically an order of operations problem. So, now what?
Can you add the 8 or
No, because that's not actually an 8. Yes, because the left side is all under the square root. We can get rid of the square root pretty easy by just squaring the entire left side and squaring the right side. So on the left side, the only thing that happens is the square root goes away. So we get x minus 8. What will the right side become?
49.
Okay, you guys remember earlier how I said this might be a problem when you do square the negative over here? So if I add 8 now, I get x equals 57.
Why is squaring a negative a problem?
Because like negative 3 squared is 9, but square root of 9 is positive 3. So that's kind of why it doesn't work. Let's see, so if I plug 57 back in, 57 minus 8 is 49. What's the square root of 49?
7?
7 plus 9 is not 2. This is actually not a solution. It's an extraneous solution. So there is no solution. If there was another answer, like some problems we did this year had 2 answers, 3 answers. There would still be a solution, but in this case, there is no solution. It's impossible, so I'll just put the no solution symbol.
Wait, why? Hold on. Back up like 2 steps.
Okay, so I got 57 to come out, but when I checked it by plugging it back in, all this stuff did not equal 2.
Okay.
So, yeah, that's one of those things that were probably like one of those on the chapter review, one of those on the test, one of those on your ACT, that kind of thing. So you gotta watch out for it, I guess. But anytime you're solving an equation, you can always check your answer. But sometimes when you square both sides, you get an extra answer, yeah.
So the reason it doesn't work is because it comes out with a positive 7, right? Or positive whatever.
Well, this came out as 7 plus 9, which is 16, and not 2. Like if I plug 57 in, I get 57 minus 8 is 49. Square root of 49 is 7. So it came out as 7 plus 9, which does not equal 2. If it had been negative 7 plus 9, that would have worked. But that's kind of the problem you get when you square. Sometimes you get an answer that doesn't actually work.
But if you were to put the 9 over in its spot over there, like do things to put it on the other side of the equation, and then
By subtracting 9, you mean?
Yes.
Okay.
And then you did your square root of square root of 49. Technically, it could be either 2 or 7.
No, a square always comes out as positive, not negative.
Okay.
That's kind of like their definite, how it always
Right.
works.
Right.
Like if you plug in square root of 49, your calculator will never say negative 7. It always says positive 7. Even though negative 7 squared is positive 49. Okay. Clear as mud? Yeah, okay, good. 11. 2 to the x equals 16. Okay, this is new. We did something kind of like this a couple, I don't know, maybe this Friday or something. So what you want to do on this problem, actually you can kind of play around with it and find the answer pretty easy. You guys know, like I could plug in what's 2 to the third, what's 2 to the fourth, what's 2. But the way they want you to do it, and this will come into handy later, 16 can be rewritten as a power of 2. Like 16 is, we need to do this for later basically. How many 2's multiply to get 16? 2, 4, 8, 16, yeah, 2 to the 4. So x equals 4. So if you have the same base here, then these exponents have to be the same, right? If these are both 2's, then these x and 4 have to be the same. X equals 4. Okay, 13. 9 to the x equals 27. This one's trickier. Both of these can be rewritten with a base of
3.
3. You guys remember 27 was a power of 3? 9 is 3 to the what?
2.
3 squared. So this 9 to the x becomes 3 squared to the x. You guys remember what power of 3 was 27?
3.
3 to the third, yeah. If you weren't sure, you could plug it in your calculator, like 3 to the third equals 3. Anyway, 3 squared to the x is 3 to the what? 2x equals 3 to the third. Okay, if the bases are the same, then that means the exponents need to be the same to make these two equal. These are both 3 to the what equals 3 to the what. These two what's need to be the same. 2x equals 3. And that's how we're going to solve it. You guys get that?
Yeah.
If the base, now that the bases are the same, the exponents need to be made the same. So what x value do I need for 2x to be equal to 3? So solve this for x. 3 divided by 2 is Well, you could say it's like 1.5 or 1.5, or you could just leave it as 3/2. You guys know how we could check this answer?
Plug it back in.
Yeah. Does 9 to the 3/2 equal 27? Question mark. You plug that in, you should get 27. Basically, you guys remember how the exponents worked here? It's basically square root of 9 cubed. Square root of 9, George, you missed this stuff, is 3, and 3 cubed is 27. So it does work. Actually, Jaden, have you done something like this chapter before, or is this kind of new for you too? Kind of new. Yes, yeah. You kind of missed the first week, so that might be a challenge. Number 15. 5 to the 3x plus 1 equals 25. You guys remember what I did on the last problem? You're right. Well, yeah, I made them have the same base. So 25 can be rewritten as 5 to the second. I'll just leave this one alone. And then what do I do?
3x plus 1
Right. I need 3x plus 1 to be equal to 2. Once the bases are the same, the exponents need to be the same. So, back to Algebra 1, or maybe 7th grade algebra. Subtract 1, divide by 3, x is 1/3. We're getting close, we're almost there. 17, 19, 21. There's not really much different. I think it's just the B section, so they're supposed to be a little bit harder. But 17, t squared of 3 plus 2. Yep. All right, any ideas what we could do first? Simplify, yeah. That's too small to simplify, square root of 3. But square root of 27 is 3 square root of 3. So I'll rewrite it like that. Now what? I think you're thinking of the last problem. It's more like number 1. So, I know these square roots look weird and their concept is kind of weird. Square root of 3 is like 1.4. It's an infinite decimal. That's why we don't write it. We don't solve it because it's a weird decimal. But it's kind of like, it's basically the same idea as solving this. Like you subtract 2, you divide by 3. You subtract 2, which does not mix well, and divide by square root of 3. Same idea as this. Okay. So minus 2, that does not simplify, but you still need to bring it over there. So the right side is just 3 square root of 3 minus 2. And what was my last thing here? Instead of like dividing by 3, I'm dividing by square root of 3. So it looks like this. Okay. I can't divide both of these terms by square root of 3. This one I could, this one I can't. So I can't cancel that out because I can't cancel that with anything over here. But basically, we're gonna do what we did yesterday. You can't leave a square root in the denominator, so I'm gonna, if you have a nice calculator, you can do it at this point, but I'm gonna multiply top and bottom by square root of 3. And on the top, that's a distributive problem. Can you guys tell me what the bottom is? 3. On the top, square root of 3 times square root of 3 is 3, times another 3 is 9, minus 2 times square root of 3. Stop right there.
What number are we going to?
22. He didn't say anything about it. I don't think he has the angle to actually read that because that little box thing's in the way.
No. I can see it. I can't see the page number. I don't know why I asked, but I can read that. Better than the 5 from yesterday.
It was an 8.
That was not an
That
8.
was a 5.
That was not.
It was an 8.
That was not an
It
8.
was a
We all thought it was a 5.
It was
That's what it looked like.
It was neither.
That's
Shut
bad.
It might not have looked like an 8, but it was not a 5. What 5?
I sure did write 5.
Got way too much
Like,
drama out of that.
Yeah.
Alright.
5 goes around and like through.
What? And it just stops like that.
It literally stopped. It wasn't
Literally
like
went,
I wrote 8, but
and
that's
then it
what I
like
heard him
stops
say.
there.
no, it just looked like not a 5.
Which looks accurate. Who jumps
Looks like it stopped like there. Like
It
it didn't go all
like
the way
stopped-
through, but the
Okay, I don't think you guys are gonna like this one.
It's no solution.
May not have been a 5.
Okay, so I noticed that both my terms have a y in them.
Divide by y.
So I'm not gonna divide by y. What I'm gonna do is factor, kind of, you're close. I'm gonna factor the y out. Do you guys remember take stuff out from the factoring? We've done it before.
No.
We're gonna take a y out of both of these. So that's gonna leave me with square root of 6 minus 3, like that.
But is this how we have to do it, or is this
This
just
is the only way.
why?
It's a new trick. I know.
Mr. George told you so.
Because you need to get y by itself. And before we get y by itself, we kind of need to get our y's together, and that's the only way they really mix.
Is it not 2y because you're taking 2 out, it's just 1?
Taking 2 out.
No, if you're factoring it out by multiplication.
When you divide by, basically when we're taking stuff out, we're dividing it out. Because if I put it back together, I'd multiply it back together, right?
Oh.
So I'm dividing the y out, which just basically makes them disappear off of each term. So now I've got all this stuff is multiplied to y. Like, you can think of it as one term because it's all in the parentheses. So how do I get rid of all this stuff if it's multiplied to y? Divide it. So I'm going to divide both sides by square root of 6 minus 3. We're getting in the big leagues now. Okay, but what's the problem with my answer there?
Square root.
You have to do the
Square root of the denominator. So this would be another place where a nice calculator would come in handy. You guys remember how to do it by hand if there's
Is it called the conjugate?
the conjugate? Yes, we multiplied by the conjugate. This was yesterday for those of you who weren't here. We did this. Have you checked your calculator yet? See if it worked on this stuff? It does work, okay. Congratulations, I know Jordan's works. Okay, and then,
Too bad Jordan doesn't work. That was uncalled for.
so the top is 2 square root of 6 plus 6. And the bottom, so it is a FOIL problem, but remember the outside inside cancel out, so really you only need to do the first and the last. So what's square root of 6 times square root of 6? 6 mine, and then the last, negative 3 times 3, negative 9. So the bottom is negative 3. Okay, that's fine as the answer. However, if we look this one up in the back, this is probably, I'm guessing this is what it will say. I'm not sure. Actually, they might put the negative out in the front there. They probably put the negative out in front now that I think about it.
That's what my calculator did.
Put the negative right there. Sometimes the book multiplies everything by -1 if they want something to be positive, like the denominator. So it might look like that. Just, that's what I'm saying. This is why we had to mix up in the grading on the last assignment. Just leave it like that though.
Uno más. N cubed root of 2 plus cubed root of 2 equals 3 cubed root of 2.
This one's actually easier than the last one. The last one was kind of a new trick for us.
Ed stands for
How many cubed root of 2? 3.
Alright. So I know this looks weird, but it's kind of like 2n plus 2 equals 3 times 2. I mean, this basically, that's what's going on here. So how do I get n by itself?
You would divide.
Get rid of the added value for, actually we could use the same trick as last time and take a cubed root of 2 out, but let's think of it like normal. You subtract the added value first, right? Subtract the cubed root of 2. Do these two mix?
Yeah.
Yes, they do. What does that become? 3 minus 1. 3 of these minus 1 of these is 2 of these. 2 cubed root of 2. Almost there. What am I missing?
Divide by.
Yeah. Divide this, it's multiplied to the end, so I just need to divide it off. What's gonna happen when I do that?
And it divides out.
Yeah, cancels out. So it's a nice, neat little 2. Why am I not checking my answers? I could check my answers, but really you only have to when you use the square both sides trick. You have to do square both sides when you have like square root of x, not just a normal x. That's the difference.